Okay, Advanced Math, Unit 12, Morning Review, Part 2. Yesterday in class we went up to number 10, and we're going to continue on number 11 through 14. It gives us information that log base 3 of 5 is m and log base 3 of 8 is n. Rewrite these in terms of m and n. A few things you have to remember. Should you be using your log laws when you're doing these? Yes. If you didn't use your log laws, you've done something wrong. Second thing is there's always a should know. Log base, whatever base they gave you, what base is this? So log base 3 of what? 3 equals 1. If the base were 10, what would you use? Log base 10 of 10, or log of 10 equals 1. Okay, so remember, what are the three things that we can use? Okay, give me a second. Anyone else need one? Wasn't here yesterday, didn't get one. He was getting it for her. Did I give you 2 of them? Sorry. All right, no one else? Okay. So, what three things are properties that we're allowed to use? The three things that we use in our log laws when we rip them apart. What is it? Multiplication, division, and powers, or exponents. Now, when you're using the multiplication and division, you're only allowed to use the 5, the 8, or the 3. Okay, 5, 8, or 3 when you're using multiplication and division. Your powers, your exponents, you can use any number. 2, 1/2, 3, 5, 7, anything. Okay, so this here is where you're restricted to those 3 numbers. All right, 40. I can see that 40 at least divides by 5. Do you guys all agree with that? Okay, so I'm going to at least break down the 40 first. 40 equals 5 times what? 5 times what? I can't hear you guys. 8. Now I can break 8 further down, but do I have to? No. All right, so can I rewrite this as log base 3 of 5 times 8? Is this the same thing as what I was given? Yes. Yes. All right. Now here's where kids say, oh, it must be then m times n. Is that correct? No. Have I used my log laws? Plus. Good. It's plus. I rip them apart. Log base 3 of 5 plus log base 3 of 8, and log base 3 of 5 is m plus n. And that there is your final answer. Your final answer should have plus signs, minus signs, coefficients. They shouldn't have powers or multiplying or dividing. Okay, next one. Any guesses on the log base 3 of 25? There's more than one way to think of it. Can I have anybody throw out any ideas? Okay, 5 times 5. Everyone agree? Okay, anything else? What? Yes?
5 squared.
Or could we have done it as log base 3 of 5 squared? Would they both work? Yes. On this one, if you ripped it apart, oh, do I have to rip this one apart, or can I plug in m times m? Do I have to rip this apart using my log laws, or can I leave it like this and write it as m times n because it's 5 times 5? I can do it this way? The answer is no. A lot of kids do it, which is why I'm asking. Remember, you have to use your log laws. These here that you have to use when you're rewriting should not be in your answers. Your final answer should not have multiplication, division, or powers. And by multiplication, I mean m times n, or m squared, or n cubed. Nothing like that. Okay, so we have to separate it. Log base 3 of 5 plus log base 3 of 5 is m plus m, which is what? 2m, which is not the same as m times n. Okay, Now, what if we did it this way? Was it Jason that told us this way? If you did it this way, what log law would you have to use? We've been using it a lot lately in the solving section. Drop it to the front. 2 times log base 3 of 5. And what is log base 3 of 5? M. So this multiplication is okay, 2m, like 2m, 3m, but not m times n or m divided by n. Those are the answers you should not have. What do you think a common wrong answer kids give me right here when they see 5 squared?
M squared.
M squared. They say, oh, it's m squared. Is that right? No, it's not. Remember, your final answer should not have any exponents. 2m. All right. 4th root of 5. Is 5 one of the numbers I can use? So 5, how can I rewrite 4th root of 5? Because I don't have anything up here with the 4th root. 5 to the 1/4. Now I said powers can be any number as long as your bases are 5, 8, or 3. Okay. Do I plug it in? M to the 1/4? No, what do we do with the 1/4? Move it to the front. 1/4 times log base 3 of 5. And what do we do? 1/4 times what? 1/4 times m. So that multiplication or m over 4 division is fine. Again, you shouldn't divide by n or n to the 1/4 power or anything like that. All right, how you write that is up to you. Next one. 72, what can 72 break down to? Anybody have any numbers? 9 times 8. Okay, do I have an 8 already here ready to go? Okay, I don't have to break that down. I don't have a 9 there or there. Which one am I going to use, the 5 or the 3? Okay, so I'm going to rewrite it then as what? 3 times 3 times 8. If you wanted to, could you write it as 3 squared times 8? Yes. Anyone have a preference on how I write it? Separate, 3 and 3, or 3 squared? 3 squared, thank you. Log base 3 of 3 squared plus, I'm sorry, yes, I'm going to write it as multiplication first, times 8. Okay, 3 squared is 9, 9 times 8 is 72. Is this the exact same thing that was originally given to us?
Yeah.
Okay, so I haven't changed the value, what it's worth, I just changed the way it looked. So we can now break it up using what? Addition or subtraction? Addition. Do you guys agree I have to break it up? I cannot plug in and say 1 cubed plus n. I can't do that. Okay, so log base 3 of 3 to the 3rd plus log base 3 of 8. Okay, what do I do with that power?
Wait, isn't it?
Oh, squared. Thank you very much. Okay, what do let me fix it first. What do I do with that power? Okay, guys, need you listening. 2 times log base 3 of 3 plus log base 3 of 8, and now we are ready. What is log base 3 of 3? So 2 times 1 is? Plus, what's log base 3 of 8? What? N. So n plus 2 or 2 plus n. Definites on the test. I suggest you go through and review these because this is where a lot of kids mess up. I get a lot of answers that look like this, m squared or m times n. Remember, I don't put everything on there. I typically put the ones kids struggle with. Between that and the review number 2. Okay. Guys. Okay, are we ready? Graph, guys, I don't know if it was this class or my 6th period where I talked about, because they were like, oh no, we need to know how to graph. What you need to know is what the graphs look like so you can match them or describe them. Okay, we know one looks like this and one looks like this. And they always go through 0, 1. Do you guys remember that from last year? You did these a whole lot last year. Which one was growth and which one was decay? This one right here is growth. This one is decay. And how do you know when you look at a function whether you're, like when you look here, how do you know which one's growth and which one's decay? What do you look at? This value right here? Yes? Okay. If it's greater than 1, it is growth. And if it's less than 1, it is decay. Okay, so let's look at this one. They're both fractions, 2/3, 3/2. Kids are like, oh, all fractions are decay. That's not true. 2/3 is growth or decay? Decay because 2/3 is less than 1. Do you guys agree? Okay, so all you need to do is that, and you're good. Okay, 3/2 to the x, growth or decay?
Growth.
Why is it growth if it's a fraction? Good, because 3/2 is 1.5. It's bigger than 1. Okay, so the kind of questions they'll ask, they'll give you a function like this and ask, you had one on your review, is it, I'm trying to remember the wording, is it going up as x increases? This graph right here, is it going up or going down as x increases, meaning when it's going this way?
Down.
So it's going down. Do you agree? So if they said on this function, they just gave you this and said, is this graph going up or going down as x increases? Oh, I'm sorry. I'm going to repeat it. They give you this function and they say it's going up as x increases. Would that be true or false?
Yes. False.
False. If they gave you this one, they didn't give you the graph, they just gave you that and said it's going up as x increases. True. Okay, so when they give you this, should you know whether it's an increase or decrease, whether it's going up or down as x gets bigger? Yes? All right. Questions at all before we move on to the last bit of it?
Do we get these formulas?
Yes, those formulas will be given to you. Hello, Mrs. Torres.
Good morning from this.
Okay.
I think I know what that call is about. She changed it to a quest.
It's a quest now.
It's a quest?
No, it wasn't.
Yes.
No. All right, listening. What interest rate is needed to triple the value of an initial investment if the interest is compounded monthly? Okay, is that the PERT or the longer one? The longer one? Why? Not why. Yes, because it's compounded. Where is it at? Monthly. What words would it need in order to compound? Good. In order for it to be the PERT, it would need to compound continuously. Do you guys all agree? Okay. So A equals P parentheses 1 plus R over N raised to the NT. This will be given to you, but do you need to know when to use it and what all the letters stand for?
When they say like semi-annually, what do they mean?
Twice a year.
Twice.
So semi-annually would be twice a year. Quarterly would be 4. Monthly would be 12.
And then, okay.
And then 3 times a year or tri-annually. Okay. Are we good? What interest? Okay, let's just label. P is the initial amount. Do we know the initial amount? No, it didn't give us. Okay, I'm going to leave it blank for now. 1 R equals, what's the rate, or is that what we're looking for? Okay, N is the number of times compounded. I heard a few of you during the quiz, what does N stand for? You need to remember, because I'm not going to give that part to you. It's the number of times compounded. And what does N stand for, or what is it in this problem? 12. Okay, T is the time. How long are we investing this money? 20. And A is the amount you're left with after given time. When they don't give us the original amount or the ending amount, what do we put for the original? 1 for the original, and for the ending amount I put 3. Okay, I heard of, is it half, is it 2, is it 3? It's not always 3, do you agree? How do we know it's 3 in this problem? Because it says triple. If it said double, what would it equal? 2. If it was a half-life problem, what would it equal? 0.5 or half.
P will always be 1 if it's not given.
If it's not given, P is 1, and your ending is 2 or 3 or 1/2. Just all depends on what the problem is.
Okay.
Okay? All right. So 3 equals 1 parentheses 1 plus R we don't know over 12 raised to the N times T, 12 times 20. Okay. Typically, what would we do at this point with this number right here? Divide it. But does dividing by 1 really change anything? No. I'm just going to rewrite it, multiplying that out up there. 1 plus R over 12. What's 12 times 20? 200 and? Okay. Now, here's where kids mess up. Typically, we plug this into our scientific calculator, get a decimal, and do something like log of both sides. But am I able to plug right there, what's in the parentheses, am I able to plug all that into my calculator and get a single decimal value? Why not? Because that's where the variable is, right? It's trapped in those parentheses. What can we do to get the variable out of those parentheses? And don't use the word multiply. Reciprocal, what do we do with the reciprocal exponent? We what? We raise it. We raise both sides to the what power? Now kids are like, oh, that must not be right. We've never done the one that big. But yes, you can. It's possible. You can plug it in your calculator. That crosses out. And this is raised to the 1 over 240. Remember, do not clear the decimal once you plug it in. You leave it in your calculator. Should you use your division key or your fraction key? Fraction. Did I hear 1.004? Yada, yada, yada? Okay. So 1.004 dot, dot, dot. What does that dot, dot, dot mean when we do it?
Still going.
It's still going. We're not rounding. Parentheses. Actually, I don't need parentheses. Equals 1 plus R over 12. Now, anybody know what your next 2 steps are going to be after this? Minus 1. Minus. Raising it. Okay. So minus 1 and then what? Times 12? All right, you guys can go ahead and do that all in one step in your well, 2 steps. Minus 1 equals, make sure you hit your equals, and then times 12.
How many spaces do we go?
Um,
3 spaces.
oh, sorry. Let me see what I've done. Yeah, as a percent, you want 2. So if 0.055 or what? 55%. Sorry. I don't know why I wrote it that way. Yes, 5.5. Sorry.
What would you take on a test?
Yes. Yeah, not 55. What was that? No, it's okay. Unless it specifies word around. I don't know if it does. All right. Shh, guys, stop the talking. Okay, so 0.055 or 5.5%. Okay, stop the talking. Next one, a radioactive substance has an initial amount of 160 grams. After 5 hours, 37 grams will still remain. Write an hourly exponential decay function in this form. Then solve for the number of hours for the half-life of this substance. Okay, wow. I'm going to actually underline so we don't forget what they're actually asking us. Then solve for the number of hours for the half-life of this substance. So in the end, we're looking for time, the amount of time it takes for it to end up with half of what it started with. Okay, this is the one on the test where I told you guys when we did the worksheet, there was like parts A, B, C, and I said they're not going to have all those parts, it's just going to ask the question. Luckily, it at least told us what should we do first. Write an hourly exponential decay function. They even gave you the form to use. So luckily for us, they've at least given us hints on what to do first. Once I find this function, is that going to be my final answer? No, I'm going to use that to actually find what they're asking us for. Oh, never mind. Okay. So we plug in. A radioactive substance has an initial amount of 160. Where does the 160 go? A, because that's always your initial. B, do we know B? Is that what we're looking for? That's what we're looking for. They didn't give us the decay rate. So times B raised to, they did give us the time. How much time has passed? And after 5 hours, how much is left? 37. Do we have enough here to find B? Yes, what do we do to both sides? Divide by 160. Leave the decimal in your calculator. The reciprocal?
That one, yeah.
Okay. So 37 divided by 160, did you get 0.231? 31 dot 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 equals b to the fifth. Now Jessica said what to do next, and what was that? Oh, I often have kids say log of both sides. Is this a log of both sides problem? No, my b is the base. What do I raise both sides to? 1/5. So leave that decimal in your calculator and raise it to the 1 fraction 5 power. Anybody have it? 746. Okay. Yes.
So like on the review, there's a problem like that. You divide the number by 60. So I did it on here, and I divided each of those numbers by 60, and I did all the work. I still got the same answer, but is that wrong?
What does that say?
You divided by 60 instead of 160?
No. I divided the 160 and the 37 by 60. Got that into the decimal. Because that's what you did on the routine number 2.
I'll come look in a little bit. All right. Yes.
So, say for example, we already had B.
Uh-huh.
What would B represent?
What does B represent?
Yeah.
B represents the rate at which it's decaying. It's your decay rate. Like these 2/3 and 3/2 over here, that's what B is. It's your growth factor, your growth rate or decay rate. Okay, so let's write down, I'm going to come this way. Y equals, A is your initial amount. What's the initial amount? 160. Parentheses, what is B? We just found it to be 0. What? Raised to the, do I use the 5 or do I go back to the x? Because I'm looking for a function. When I'm writing a function, x stays x and y stays y. I only plugged in the 37 for y and the 5 for x over here so that I could solve for b. Once I have b, x goes back to x, y goes back to y. Put your phones away, please. Okay, this is not my final answer. But do you agree this is now what I'm going to use to solve for its half-life? Okay, so this is one that requires a lot of work. And in your workspace, do you need to show all of this? Yes. All right, so now we're ready for the final question. Oh, and to give you a hint, plug in information and solve for B. That's what we did over here. Okay, then solve for the number of hours for the half-life of the substance. We're looking for the amount of time it takes for us to end up with half of what we started with. So what is y going to equal if we're looking for half-life?
80.
Where did you guys get 80 from?
And this says 160.
160 cut in half. Good job. Okay.
So you have the initial amount.
Yes. And yeah, what they're asking for half-life, you have the initial amount. And if the initial amount was not given, initial amount is 1, and this would be what? 0.5 or 1/2. Got it?
So if it's not given, it's 1.
In this problem, it had to be given for us to come up with the equation. But let's say they gave us this function and they asked us to find the half-life, but they didn't give us, like this was a letter, you would make this 1/2, and that right there would be 1. And then the rest would stay as is. Got it? Okay. So let's go ahead. And you're going to see that it works out that same way anyway. What are we going to divide both sides by? 160. And what's 80 divided by 160? So does it end up being 1/2 on this side and 1 on this side, just like it would have been had we plugged in 1 and then the 1/2? So it works. 0.746 raised to the x. There are a lot of these on the test where you have to look and figure out what to do. Is this a reciprocal of the exponent problem? No, I heard a few of you say it. What is it? Okay. Log of both sides. Hey, before I address that, am I safe right now to bring the x down?
No.
No. We have to log of both sides. Yes, Janelle? You said you had a question?
Oh, no.
No? Okay. All right. Log of 1/2 equals log of 0.746 raised to the x power. Do I divide or do I do something with this exponent first? Bring it to the front. That's the whole reason we did log of both sides. Log 1/2 equals x times log of 0.746. And we're ready now to solve. What do I divide both sides by? All right, plug it in your calculator. Don't forget to close the parentheses before you hit your division sign. Three decimal places would be what? 2.365 hours. So this right here is what you would put in your answer column. All of this is in your workspace. This is what you'd put in the answer column. Make sense? Questions? No questions?